everyone, welcome to 90 Plus My Tuition app. So welcome to a brand new session of physics class. Okay, so today we are going to discuss important questions from light, reflection, refraction, and the questions will be from reflection of light. Okay, reflection of light. So in the last week we have got a one-shot video on this chapter, light, reflection, refraction. We have discussed all the important topics. Okay, we have seen the ray diagrams, the equations, the laws and all. And today we are going to do some important questions. Okay, we need to solve some questions from this chapter. Okay, so from this chapter means from the first portion of this chapter, which is reflection of light. Got it? Okay, which is reflection of light. So good evening, okay, so it's not good evening. Okay, so good evening. Yes, Nia is telling good evening. Yes, so good evening. Good evening. Okay, so welcome. Okay, so shall we start? Shall we start light, reflection? Okay, so we'll discuss 9 important questions from this chapter. Okay, 9 important questions from this chapter. So light, reflection is the first topic. So I'm asking you the state laws of reflection of light. State the laws of reflection of light. Okay, so this is the first question, which is laws of reflection. Okay, so now what is reflection of light? Okay, we need to know that. Yes. Okay, so what do you mean by reflection of light? It's very simple. Okay, so there is a surface. Okay, there is a surface. So light is actually striking the surface. Yes, light is actually striking and it is bouncing back the light is bouncing back to the same medium. Got it? Okay, so the striking light will be the incident ray and the light which is reflecting or bouncing back is known as the reflected ray. The angle between these two, incident ray and the normal of the point of incidence, which is N, is angle of incidence, and the angle between normal and the reflected ray is angle of reflection. Then we have 2 laws of reflection. Yes or no? Yes, Nia, it's right. There are 2 laws of reflection. Okay. So the first law is the angle of incidence is equal to angle of reflection. That is I is equal to R. Angle of incidence I will be equal to angle of angle of reflection R. That is I is equal to R. Then we have the second law, which is the incident ray, the reflected ray and the normal all will be lying in the same plane. Got it? So these are the 2 laws of reflection. Okay, I hope you understood the concept of reflection. Okay, the concept of reflection. Okay, so we have incident ray, we have the reflected ray, we have the angles between them. Okay, so based on this, we will be having 2 laws of reflection. Got it? Okay, so now here comes the second question. If the image formed by the mirror for all positions of the object placed in front of it is always erect and diminished, what type of mirror is it? Okay, if you take a mirror, you keep an object in front of it, wherever you keep it, the image formed will always be erect and diminished. That is the question. So the question is, which type of mirror is it? Or mirror eduthala, okay, you keep your object evide vechalu. If you keep it in the center of curvature, you keep it at the focus or between center and focus or with infinity at everywhere. Evide vechalu, okay, you get the image as erect and diminished. What type of mirror is it? Yes, you are right. Yeah, okay, you will be that mirror is a convex mirror. That mirror is a convex mirror. So this is the table of the image formation of a convex mirror. I hope you know that. Okay, when you keep your object at infinity, look here, virtual and erect, highly diminished image. When you keep your object between infinity and pole of the mirror, then also you are getting the image as virtual and erect and also diminished. Okay, so that is the question. Wherever you keep your object, your image will always be virtual and erect and also diminished. So what is that type of mirror? It's a convex mirror. Got it? It's a convex mirror. Got it? So very important. This table very important. And how can we make this table? Idella nammal one shot la padichittulla കാര്യങ്ങളാണ്. ആണോ? Yes, we have actually discussed this chapter in detail. So I hope you see that also. Okay, hope you see that also. Yes, fine. So here comes the third question. The third question. When an object is kept within the focus of a concave mirror an enlarged image is formed behind the mirror. The image is real, inverted, virtual and inverted, virtual and erect. Okay. So here you have a concave mirror. In the question itself it is given that it's a concave mirror. So here you are keeping your object within the focus of a concave mirror. Okay, within the focus of the concave mirror. You are keeping your object within the focus. That means you are keeping your object between the focus and the pole of the mirror. Okay, within the focus of a concave mirror, you are keeping your object between pole and the focus. അങ്ങനെയാണെങ്കിൽ ആ കേസിൽ ഉണ്ടാവുന്ന ഇമേജിന്റെ സൈസ് തന്നിട്ടുണ്ട്. ഇറ്റ്സ് an enlarged image. You are asked to find the nature of the image. So there are four options. Okay, which case it is? ഏത് case ആണിത്? If you look at the table of a concave mirror, you can see that it's the last case. It's the last case. Okay, you are keeping your object between the focus and the pole. Adanana within the focus of a concave mirror nu parnalum. Okay, so this is the figure of it. You can see that the image formed is erect image. It's an erect image, and ഇത് ഇതിന്റെ റേ ഡയഗ്രാം പഠിക്കുമ്പോൾ നമുക്ക് മനസ്സിലാക്കാൻ പറ്റുന്നുണ്ട് ഇത് ഒറിജിനലി ഉണ്ടായതല്ല. ഇറ്റ്സ് നോട്ട് എ റിയൽ ഇമേജ്. ഇതിങ്ങനെ നമ്മൾ ബാക്കിലോട്ട് എക്സ്റ്റെൻഡ് ചെയ്ത് വി ക്രിയേറ്റഡ് ദാറ്റ് ഇമേജ്. ഗോട്ട് ഇറ്റ്? വി കാൺ സീ ദാറ്റ് ഓൺ ദ സ്ക്രീൻ. So it's a virtual image. Okay, അതാണ് dotted lines ൽ നമുക്ക് ഇവിടെ കാണാൻ പറ്റുന്നത്. Okay, so the answer is option number D. It's virtual and erect. It's not inverted. You're getting it as straight. Got it? Okay, so the answer is option number D, virtual and erect. It's not a real image. It's not an inverted image. It's not virtual and inverted. That is not applicable. Okay, it's virtual and erect. Got it? Yes. So here comes question number 4. State two positions in which a mirror produces a magnified image of a given object. Okay, yes. Let's do differences between two images. Okay, so the question is that only the mirror is given. Okay, they didn't specify which mirror is it. Okay, they didn't specify which mirror is it. We know that there is a convex mirror, there is a concave mirror. They didn't specify the mirror, the name of the mirror. ചോദ്യം ഇതാണ്, ഒരു മിററിന്റെ അവിടെ ഒരു ഒബ്ജക്റ്റ് വെച്ചാൽ യു വിൽ ബി ഗെറ്റിംഗ് മാഗ്നിഫൈഡ് ഇമേജ്. അങ്ങനെ മാഗ്നിഫൈഡ് ഇമേജ് കിട്ടുന്ന രണ്ട് കേസസ് എക്സ്പ്ലെയിൻ ചെയ്യാനാണ് പറഞ്ഞിരിക്കുന്നത്. ജസ്റ്റ് സ്റ്റേറ്റ് ഇറ്റ്. ഗോട്ട് ഇറ്റ്? ഓക്കെ, സോ ഇഫ് യു കീപ് a object in front of which mirror? Okay, whether it is in front of a convex mirror or a concave mirror, എവിടെയായിരിക്കും നിങ്ങൾക്ക് മാഗ്നിഫൈഡ് ഇമേജ് കിട്ടുന്നത്? Or where will you get a enlarged image? That is the question. Okay, so now if you look at the table of a convex mirror, മുന്നേ നമ്മൾ ടേബിൾ കണ്ടല്ലേ convex mirror ന്റെ കേസിൽ. Okay, I'll show you the table of a convex mirror. This is the table of a convex mirror. Here you can't see a magnified image. ഇവിടെ നിങ്ങൾക്ക് ഒരു magnified image ഒരിക്കലും കാണാൻ പറ്റില്ല. Look at the size. In the case of image formation by a convex mirror, you will only be seeing diminished image. Okay, so അങ്ങനെയാണെങ്കിൽ എവിടെയായിരിക്കും എൻലാർജ്ഡ് ഇമേജ് നിങ്ങൾക്ക് കാണാൻ പറ്റുന്നത്? എവിടെയായിരിക്കും എൻലാർജ്ഡ് ഇമേജ് നിങ്ങൾക്ക് കാണാൻ പറ്റുന്നത്? ഇൻ ദ കേസ് ഓഫ് എ കോൺകേവ് മിറർ. ഓക്കെ, സോ ദിസ് ഇസ് ദ ടേബിൾ ഓഫ് എ കോൺകേവ് മിറർ, ഇമേജ് ഫോർമേഷൻ ഓഫ് എ കോൺകേവ് മിറർ. ഹിയർ യു ക്യാൻ സീ ദാറ്റ് ദർ ആർ എൻലാർജ്ഡ് ഇമേജസ് ഫോമിങ്. Okay, enlarged image kittunna cases undu. Where in the case of image formation by a concave mirror. Okay, concave mirror case il maatrame you will be seeing enlarged images. So adinte positions oda parayan pannittundu. Where will we getting this enlarged images? So in the case of the fourth one, between, if you keep your object between center of curvature and focus, you will be getting a enlarged image. Yes, and if you keep your object between the pole and the focus, there also you will be getting an enlarged image. Yes or no? Yes. So that's an important question. Okay, if you know the table only, you can actually answer that question. Got it? Yes. So in the question, one more thing is given. Just give differences between the image formed. Okay, so in the case of the fourth image, okay, you can see that the image formed is real and inverted. So that is one of the difference. Look here, in the case of between pole and the focus, the image formed is virtual and erect. അപ്പോൾ ഒരിടത്ത് real and inverted, ഒരിടത്ത് virtual and erect. The nature is different. So that is one of the difference. Got it? Yes. And the second difference, the position of the image is different. Okay, so if you keep your object between the center of curvature and the focus, you can see that the image is formed beyond C. So that is one of the difference. Look here, in the other case, the image is formed behind the mirror. Okay, behind the mirror. So these are the two differences. These are the two differences of the image formed. Got it? Okay, so it's a very important question. Very important question. Okay, so the state two positions. You need two positions. So you can actually answer that from the table, and the differences are also there. You can actually answer the differences in terms of the position of the image and nature of the image. Got it? Yes. Fine. Now here comes the fifth question. The fifth question. Name the type of the mirror. Okay. Name the type of the mirror used in the following situations. Okay. കുറച്ച് സിറ്റുവേഷൻസ് തന്നിട്ടുണ്ട്. ആ കേസിൽ ഏത് മിറർ ആയിരിക്കും യൂസ് ചെയ്യുന്നത്? വെദർ ഇറ്റ്സ് എ കോൺകേവ് മിറർ ഓർ എ കോൺവെക്സ് മിറർ. ദാറ്റ് ഈസ് എ ക്വസ്റ്റ്യൻ. ഓക്കെ, ദ ഫസ്റ്റ് വൺ, ഹെഡ്ലൈറ്റ്സ് ഓഫ് എ കാർ. കാറിന്റെ ഹെഡ്ലൈറ്റ്സിലെ ഏത് മിറർ ആണ് യൂസ് ചെയ്യുന്നതെന്നാണ് ചോദിച്ചേക്കുന്നത്. യു നോ ദാറ്റ് വി ഹാവ് സ്റ്റഡീഡ് ദി യൂസസ് ഓഫ് മിറേഴ്സ്. ഓക്കെ, ഇൻ ദ കേസ് ഓഫ് ഹെഡ്ലൈറ്റ്സ് ഓഫ് എ കാർ, you will be using a concave mirror. Okay, you will be using a concave mirror. Okay, and the second one, why are we using a concave mirror? We need to, okay, produce parallel beams of light. Parallel beams of light to get it up. So obviously you will be using a concave mirror. Got it? Yes. Now the second one, the side or the rear view mirror of a vehicle. Okay, in that case, which mirror is used? Rear view mirror in the case, side mirror in the case, normally they, side mirror or the rear view mirror, they will, which type of mirror is it? Which type of mirror is it? Yes, we will be using, yes, you are right, Nia, you are right, we will be using a convex mirror. Okay, we will be using a convex mirror. Why are we using a convex mirror in this case? Because we need to get erect images, diminished images, virtual images, erect images ഒക്കെ കിട്ടണം, and we need to get it in the larger view. Traffic ഒക്കെ കാണണം അല്ലേ, പുറകെ വരുന്ന വണ്ടി എല്ലാം കാണണം. Okay, so അങ്ങനെയാണെങ്കിൽ we need to get a larger view, okay, of the traffic and all. Okay, so that's why we will be using a convex mirror. Got it? Yes. Now the third one, solar furnace. Solar furnace in the case we will be using, yes, we will be using a concave mirror. Okay, we will be using a concave mirror. Got it? Yes, there also we need to produce parallel beams of light. Now the fourth case, dentist. Okay, when you go and visit a dentist, they also use a mirror. You can see that. Yeah, okay. So the question is, which type of mirror is it? Okay, whether they are using a concave mirror or whether they are using a convex mirror, which type of mirror is it? That is the question. Yes, which type of mirror is it? Okay, when you go and visit a dentist, obviously they will examine your tooth and all, right? Yes. So at that case, what is the use of that mirror? They want to see an enlarged image. Okay, നമ്മുടെ ഈ വായിക്കകത്തുള്ളതിൻ്റെയൊക്കെ എന്താ enlarged image കിട്ടണം. We need to get an enlarged image, magnified image കിട്ടണം. അന്നേരം ഉള്ളതിനേക്കാളും കുഞ്ഞായിട്ട് കാണിക്കാൻ പറ്റില്ല. Doctor wants to examine the tooth, right? Yes. So we need to get an enlarged image. അങ്ങനെയാണെങ്കിൽ my question is, which mirror gives you an enlarged image? Which mirror will give you an enlarged image? Yes, ഇപ്പം തന്നെ നമ്മൾ കണ്ടതേ ഉള്ളൂ. Concave mirror will give you an enlarged image. Okay, concave mirror is going to give you an enlarged image. Got it? മനസ്സിലായോ? So some things you need to understand from the tables, okay, and then you can identify. Got it? Okay, so this is a very important question. This is a very important question. Application or uses of mirrors. Okay, application or uses of mirrors. Yes. Now here comes question number 6. That is, why do we prefer a convex mirror as a rear view mirror in vehicles? The reason for that. Okay, just now we have discussed that. Okay, in the case of a convex mirror, we will always be getting virtual, erect, diminished images. Wherever you keep your object, you get virtual, erect and diminished images. And also, we need to get a larger area view of the traffic behind them. So obviously, we need to use, yes, we need to get a wider field of view. So obviously, we need to use a convex mirror. Got it? Got it? So it's a very important question. It's a very important question. Normally, ഇങ്ങനെ ഒരു ക്വസ്റ്റ്യൻ പ്രതീക്ഷിക്കാം യൂസസ് ചെയ്യുന്നത്. കേട്ടോ? Okay, fine. So here comes the next question. Consider the following diagram. Okay, a diagram is given in which M is a mirror. This is a mirror, and P is the object. P is the object. Q is the image formed. Okay. And one more thing is given, that image is magnified. It's a magnified image. Okay. Fine. You are asked to find which mirror is it. Okay, you need to identify that M. M ഏതാണെന്ന് identify ചെയ്യണം, whether it's a concave mirror or a convex mirror. And also one more thing, you are asked to find one characteristic property of the Q. What is this Q? It's the image. Okay, so P is the object, M is the mirror, Q is the image. You are asked to find what is this M and the property of this image. Got it? Yes. So if you identify, if you look at this, you can see that the object is between the focus and the O. What is this O? Optic center. Okay, got it. Yes. And the image formed is behind the mirror. Image എവിടെയാ ഫോം ചെയ്തേക്കുന്നത്? മിററിന്റെ ബിഹൈൻഡ് ആയിട്ടാണ് ഇമേജ് ഫോം ചെയ്തേക്കുന്നത്. ആൻഡ് വാട്ട് ഇസ് ദിസ് പെക്യുലാരിറ്റി ഓഫ് ദറ്റ് ഇമേജ്? ഇറ്റ്സ് എ മാഗ്നിഫൈഡ് ഇമേജ്. ഒബ്ജക്റ്റിനേക്കാളും വലിയ സൈസിലുള്ളതാണ് ഇമേജ് ഇരിക്കുന്നത് അല്ലേ? വിച്ച് കേസ് ഇറ്റ് ഇസ്? ഏത് കേസ് ആണത്? ഓക്കെ, ഏത് കേസ് ആയിരിക്കും അത്? മാഗ്നിഫൈഡ് ഇമേജ് കിട്ടണം. മാഗ്നിഫൈഡ് ഇമേജ് കിട്ടുന്ന ആളായിരിക്കണം. Okay, it's very important, very important. You are getting an erect image. Yes. Okay, yeah, we discussed that it's a concave mirror. Okay, the last case, it's a concave mirror. നമ്മളിപ്പോൾ ഡിസ്കസ് ചെയ്തതാണ്. ദ ലാസ്റ്റ് കേസ് ആയിരിക്കും. നിങ്ങൾ നോക്കിയാൽ മനസ്സിലാവും. ബിഹൈൻഡ് ദ മിറർ ആയിരിക്കണം. ഇറ്റ്സ് എ മാഗ്നിഫൈഡ് ഇമേജ്. ഇറ്റ്സ് വെർച്വൽ ആൻഡ് ഇറക്റ്റ് ഇമേജ് തന്നെ കിട്ടുന്നത്. ഇറ്റ്സ് ദ ലാസ്റ്റ് കേസ് ഓഫ് എ കോൺകേവ് മിറർ. സോ ക്വസ്റ്റ്യൻസ് ക്യാൻ ബി ആസ്ക്ഡ് ഇൻ ഡിഫറെന്റ് വേസ്. ഓക്കെ, This is actually the last case of the image formation by a concave mirror. Okay, last case ആണത്. Okay, so this is actually the figure. ഇതാണ് ആ റെഡ് ഡയഗ്രാം. കോൺകേവ് മിററിന്റെ അവിടെ, ഇഫ് യു കീപ് ദി ഒബ്ജെക്ട് വിത്തിൻ ദ ഫോക്കസ് ഓഫ് ദ മിറർ, യു വിൽ ഗെറ്റ് ദി ഇമേജ് ബിഹൈൻഡ് ദ മിറർ. It's an enlarged image, it's an erect image. Okay, so you have got one of the properties of this image, which is the virtual image. Okay, the image formed is virtual. Okay, it's an erect image. ആണ് അതേ directional തന്നെ ആയിരിക്കും കിട്ടുന്നത്. It's not inverted, it's an erect image. Got it? So you have actually specified one characteristic property of the image also. Okay, so this is a concave mirror. Okay, this is a concave mirror. The image formation is the last case of the concave mirror. Got it? Understood? It's very important. It's not convex. Convex ആണെങ്കിൽ ഈ സൈഡിലല്ല കിട്ടുന്നത്. Okay, convex ആണെങ്കിൽ ഈ സൈഡ് അല്ല, you will be getting it front of the mirror. Got it? Yes, fine. Now we'll see some numerical problems. Yes. Look here, an object is placed in front of a concave mirror 20 centimeter away from it. If its focal length is 40 centimeter, locate the position of the images and its nature. Okay, yes. Okay, so if you get a question like this, identify which mirror is it. Which mirror? ഏത് mirror ആണ് അതൊന്ന് ഐഡന്റിഫൈ ചെയ്യാം. In the question itself, it's given that it's a concave mirror. Okay, so draw a concave mirror. This is a concave mirror. ആണോ? Yes, here you can see that the reflecting surface is curved inwards. അകത്തോട്ടാണ് curve ചെയ്തേക്കുന്ന reflecting surface. So obviously, this is a concave mirror. Okay, Maria, the question itself, it is given that it's a concave mirror. ആണോ? അപ്പോൾ അങ്ങനെയാണെങ്കിൽ ഒരു കോൺകേവ് മിറർ വരയ്ക്കുക. then identify or place what all things are given. എന്തൊക്കെയാണ് തന്നേക്കുന്നതെന്നൊന്ന് പ്ലേസ് ചെയ്ത് നോക്കുക. Okay, look here, an object is placed. നമുക്ക് ഒരു മിറർ ഉണ്ടെങ്കിൽ obviously you need to place an object. ആണോ? Yes, so you placed an object. എത്ര പ്ലേസ് ചെയ്തേക്കുന്നത്? 20 centimeter away from the mirror. Okay, yes, so 20 centimeter away ആയിട്ട് I kept my object. 20 centimeter away I kept my object. If the focal length of this mirror is 40 centimeter, what is this focal length? Okay, from the pole or from the midpoint of the mirror to the focus. Focus വരെയുള്ള ദൂരമാണ് focal length. So focal length is given as 40 centimeter. So this much distance is 40 centimeter. That is from the pole to the focus. Yes. So these two things are given. You are asked to find the position of images. Okay, V കണ്ടുപിടിക്കാൻ ചോദിച്ചിട്ടുണ്ട്. Okay, where is this image formed? You have your object, you have the focal length. From that, you are supposed to find where is your image. Image evideyaanennu parayanam. Okay, so now we need to denote these things, this 20 centimeter of this or this 40 centimeter. You need to denote that. Okay, you need to denote that. Yes, yes, yes. So how can you denote that? For that, you need to use the Cartesian sign convention. New Cartesian sign convention use ചെയ്തിട്ട് വേണം values assign ചെയ്യാനായിട്ട്. So from the mirror or from the pole of the mirror till or to the object, that is the object distance, is actually denoted by u, which is equal to, what is the value of it? Apply the Cartesian sign convention. You can see that, okay, according to the Cartesian sign convention, you need to assign negative sign from if it is to the left of the mirror. Okay, ഏതെങ്കിലും ഒരു ക്വാണ്ടിറ്റി മിററിൻ്റെ പോളിൽ നിന്ന് ലെഫ്റ്റിലോട്ട് ഇരിക്കുകയാണെങ്കിൽ യു നീഡ് ടു അസൈൻ നെഗറ്റീവ് സൈൻ. സോ ഇവിടെ നോക്കിയാൽ മനസ്സിലാവും പോളിൽ നിന്ന് നെഗറ്റീവ് സൈഡിലോട്ടാണ് നിങ്ങളുടെ ഒബ്ജക്റ്റ് ഇരിക്കുന്നത്. സോ ഒബ്വിയസ്ലി യു ഇസ് ഈക്വൽ ടു -20 centimeter. Yes. Now one more data is given. The focal length is given. Focal length is actually denoted as f, small letter f. Yes, f is equal to it is 40 centimeter. But you can't directly write it as 40 centimeter. You need to apply the Cartesian sign convention. So according to the new Cartesian sign convention, okay, to the left of the mirror, you need to assign negative sign. Yes? Okay, so focus is to the left. So obviously it is -40 centimeter. Yes or no? Yes. So now you have u, that is the object distance. You have the focal length. You are supposed to find v. How will we find v? How will we find v? Yes, you will be using mirror equation. Okay, you will be using mirror equation. What is this mirror equation? What is this mirror equation? Yes, mirror equation is nothing but an equation in terms of v, u and f. That is 1 by f is equal to 1 by v plus 1 by u. Okay, it's an equation in terms of focal length, image distance and object distance. In the question itself, it is given that f is equal to -40 centimeter, okay, u is equal to -20 centimeter. You are asked to find v. So accordingly, rewrite that equation. Okay, we need to find v. So we can write 1 by v is equal to 1 by f minus 1 by u. Yes or no? Yes. So substitute f and u. Substitute f and u. You have f, you have u. Substitute. Yes. So it is equal to 1 by, okay, it is 1 by -40, yes, minus 1 by -20. Yes or no? Yes, yes, yes. Now rewrite it. Now rewrite it. It is -1 by 40 plus 1 by 20, because we know that minus into minus is plus. Yes. Now take the LCM. You can actually do it in a different way. It is 1 by v. That is -1 into 20 plus 1 into 40 divided by 40 into 20. Yes. So what is that value? -20 plus 40 by 800. So that is actually 1 by v, which is 20 by 800. Okay, it is 20 by 800. So it is 1 by v. 1 by v is equal to 20 by 800. Yes, from that v is equal to the reciprocal of this. Okay, since 1 by v is equal to 20 by 800, we need the value of v, not 1 by v. So what is v? Just take the reciprocal. So it is 800 by 20. What is this 800 by 20? Yes, what is this 800 by 20? It is equal to 80 by 2, which is 40. What is the unit of distance? V is actually the image distance. So what is the unit of image distance? Yes, it is centimeters, right? Yes, it is 40 centimeters. So now we have got the value of v. Image avada form cheyidekkunnu kandupidikkanaanu choichekkunne. The value is 40 centimeter. So if you look at the value itself, you can see that's a positive value. Positive value kittan paadullu. Okay, so this is the last case of a concave mirror. In that case, you can see that you will be getting the image to the right of the mirror. Image in the right side lote kittavu. Angane thanne kittanam. Right lote ullavarokku positive values aayittu kittum. Okay, so v is equal to 40 centimeters. So that means your image is formed. Okay, that means your image is formed here. ഇവിടെ എവിടെയാണ് നിങ്ങളുടെ image? Right. 40 centimeter plus 40 centimeter na kittekune. So that means the image is to the right. Okay, the last case. Okay, last case aanu your object is between the focus and the pole. The last case of the image formation by the concave mirror. Got it? Understood? So nature is also asked. Nature enganathe nature ah endayirikkum nature positive side lotta kittekune. So obviously it's a it is behind the mirror. It is behind the mirror. Yes. Okay, it's a virtual and erect image. Erect image aanu kittekune aano erect positive value aanu erect image aayirikkum. Okay, the nature is erect image. Virtual and erect. Yes. Now here comes the last question. Question number 9. A student has focused the image of an object of height 3 cm on a white screen using a concave mirror of focal length 12 cm. If the distance of the object from the mirror is 18 cm, you are asked to find three things: the distance of the image from the mirror, the magnification of the image, and the height of the image. If you get a question like this, first thing what you should be doing, identify which mirror is it. Eda mirror aanu identify cheya. Eda mirror. Okay, in the question itself it is given that it's a concave mirror. Yes or no? Yes or no? It's a concave mirror. Yes. Now then draw a concave mirror. Yes, we have drawn a concave mirror. Good. Yes. Now what all things are given? Identify that and place it. Yes. An object of height 3 cm. Okay. So now your object has got a height which is 3 cm. Okay. So place your object anywhere here. Okay. So it has got a height of 3 cm. Got it? It has got a focal length of 12 cm. Okay. If the distance of the object from the mirror is 18 cm, 18 cm മാറി നിങ്ങളുടെ 18 cm മാറിയാണ് നിങ്ങളുടെ ഒബ്ജക്റ്റ് ഇരിക്കുന്നത്. Okay, that data is also given. It is 18 cm മാറിയാണ് നിങ്ങളുടെ ഡിസ്റ്റൻസ് ഒബ്ജക്റ്റ് ഇരിക്കുന്നത്. Focal length is also given as 12 cm. Okay, ഇവിടെ എവിടെയാണ് നിങ്ങളുടെ focal length ഇവിടെ എവിടെയാണ്. So that value is also given, which is 12 cm. Focal length, distance from the pole to the focus. So that is 12 cm എന്ന് തന്നിട്ടുണ്ട്. Now you are asked to find the distance of the image from the mirror. What is that? V. You are asked to find V. You are asked to find magnification M. You are asked to find the height of the image. Yes. Now identify what all things are there and denote it. Okay, adadu vaangal vechu denote cheya. Yeah, what is this 3 cm? What is this 3 cm? It is the height of the object. Yes, it is HO. You need to apply the Cartesian sign convention. Anything above the pole of the mirror. Okay. Principal axis ന് മേലോട്ടുള്ള ആൾക്കാരൊക്കെ എന്തായിരിക്കും? പോസിറ്റീവ് ആയിരിക്കും. സോ മേലോട്ടല്ലേ ഇരിക്കുന്നത്. സോ ഒബ്വിയസ്ലി ഇറ്റ് വിൽ ബി പ്ലസ് 3 cm. നോക്കിക്കേ, ഒബ്ജക്റ്റ് മേലോട്ടാണ് ഇരിക്കുന്നത്. സോ ഇറ്റ് ഇസ് പ്ലസ് 3 cm. Yes. Now the object distance is given 18 cm. You can see that it is to the left of the mirror. Got it? Okay, it is to the left of the mirror. All measurements are taken from the pole. Pole in the left lot ആണ് നിങ്ങളുടെ object ഇരിക്കുന്നത്. So obviously it should be taken as negative. So U is equal to minus 18 cm. Focal length is given 12 cm. So you know that concave in the case obviously നിങ്ങളുടെ focal length left ആയിരിക്കും. Left തന്നെ ആണോ? Focus അപ്പുറത്തോട്ടല്ലേ? Obviously. Yes. So focal length is also minus 12 cm because it is to the left of the mirror. Now what all things are to be found out? You need to find V, you need to find M, you need to find HI. Got it? So you have U and F. From that you can find V. UF ഉണ്ടെങ്കിൽ you can find V. How can we find V? Yes, you should be using the mirror equation. Yes, now use it. Mirror equation. Yes, what is mirror equation? 1 by F is equal to 1 by V plus 1 by U. You need to find V. V ആണ് നമുക്ക് വേണ്ടിയത്. അങ്ങനെയാണെങ്കിൽ just rewrite. 1 by V is equal to എന്ന് പറഞ്ഞൊന്ന് എഴുതിക്കേ. Yes, 1 by V is equal to 1 by F minus 1 by U. Substitute. Yes, focal length is given in the question as minus 12 cm and the object distance is given as minus 18 centimeter. Substitute it. It is 1 by minus 12 minus 1 by minus 18. Yes, what is that? It is 1 by minus 1 by 12 plus 1 by 18. That is actually 1 by V. Yes. Okay, now take the LCM. 1 by V is equal to, okay, 1 by V is equal to minus 1 into 18 plus 1 into 12 divided by 12 into 18. Yes or no? Yes or no? Yes. So, what is that? Minus 18 plus 12 by 12 into 18. Okay. Yes. Yeah. So, now what is that? Minus 6. Minus 18 plus 12 is minus 6. 12 into 18 is 216. So that is 1 by V. That is 1 by V. Minus 6 by 216. We need V. V 1 by V. 1 by V. We need V. Yes. So take the reciprocal of it. It is 216 by minus 6. 6 into 3. 6 into 36 216. So the value is minus 36 centimeter. Okay, minus 36 centimeter. Your answers are right. Okay, Biju okka parana sheriyana. It is minus 36 centimeter. Got it? So you have located the position of the image. Namakku image in position kitti V, minus 36 centimeter. Now you are supposed to find the magnification. Okay, namakku magnification oda venam. What is the value of what is the equation for magnification? What is the equation for magnification? Yes, you know that magnification is equal to minus image distance by object distance, that is minus V by U. Just now we have found V. In the question U is given, substitute it and directly find the answer. What is V? It is minus. Yes. Okay, so substitute it and find it. Substitute here. It is minus into 36 divided by minus 18. Yes. Okay. Yes, and substitute it, you will get minus 2 as the magnification. Yes, minus 2. Minus into minus 36 by minus 18. So it is minus 2. Yes, that is right. And find the height of the image. Next, you are supposed to find the height of the image. How will you find height of the image? Okay, you know that magnification M is equal to HI by HO. That is HI by HO is equal to magnification. In the question it is given that HO is there. HO is 3 centimeter in the question. Okay, yes. Just now we have found magnification. Substitute it. Okay, yes, so you will get the height of the image as minus 2 into 3, which is minus 6 centimeter. Got it? Understood? Yes, so this is how you will find the questions. Okay, this is how you will find the answers. Okay, so for this you need to understand the equations. Okay, you need to understand the equations, which is a mirror equation. Mirror equation very important. Magnification equation and this magnification equation. These 3 equations are very important and accordingly identified. Got it? Understood? Only 3 equations, then it's easy. So, all questions are very problem. Okay, height of the image, magnification, mirror equation. So, all equations are there. Okay, the numericals can vary. Numbers okay, but the concept is the same. Got it? Understood? Okay, so we'll see with part 2 of this chapter. Okay, so till now we have studied about reflection of light. These questions are discussed. We'll come with part 2 in another session. Okay, hope you have understood it. And subscribe to this channel if you have not done, because in the coming days we'll be discussing more questions. Okay, we'll be having more sessions. So subscribe to this channel if you have not done and stay tuned to our channel. Okay, yes, so see you in another session. Bye-bye.